Yeah.
Hi guys, Carl Urbanik here, my lab partner, Anire.
Hey.
Alright, and this is lab 5?
Yes.
Or the op-amp lab.
Dealing with active filters.
So if you want to come look at our circuit here, we have the LM348N amplifier chip with the low pass filter and the high pass filter. And here, right now, we're set up to test the low pass filter. If you look at the computer here, if we run the network sweep from 1 kilohertz to 100 kilohertz, which is why it's so much faster than in the actual lab, you'll see that our circuit is operational and the cutoff frequency is around...
Go back to the graph on, there we go.
Around 17 kilohertz here, 17 and a half.
17,000.
Yeah, and so
hertz, 17
that
kilohertz.
happens because the wave is then sent through this first resistor and then through the resistor and capacitor in parallel, which form the impedance that only lets low frequencies through. And so now Anire will explain the high frequency filter.
Yes. So in this circuit over here, we built a high pass filter. So with a high pass filter, it'll be able to detect high frequencies and then it will cut off at a max frequency. So if we look at our graph for that, so this is our measured response of the high pass filter. So as you can see, it levels off at a max frequency, at a max gain at higher frequencies, and our cutoff frequency was around 18.28 hertz for that. And then finally for the bandpass filter, in order to do this, we had to connect the output from the low pass filter into the input of the high pass filter. As Carl can see, output from the low pass filter goes into input of the high pass filter. That allows us to cascade the circuits together to give us a band pass filter. And if you look over here, this is what the gain of the band pass filter looks like. And if it looks familiar to you, it should, because it's really the gain of the high pass filter over here plus the gain of the low pass filter over here. So that is what the gain of the bandpass filter looks like. And now if we also look at the phase, of both of the filters now, so this is the phase of the low pass filter.
Here's the high pass.
And this is the gain of the high pass filter. So when we cascade the circuits together, we expect both the gain of the bandpass filter to be the sum of the gains for the low pass and high pass, and we expect the same thing to happen for the phase, which is shown here. So the band pass is behaving correctly, and that's our lab. Okay, 319.
Oh.
Yeah.